Hello everyone, I am Mark Lazy Gonzalez and I am the first reporter for this chapter, which is chapter 6, Analyzing and Interpreting Quantitative Data. So this topic is presented by Group 6, including Miss Costales, Hazel, Dalumpines, Andre, and including myself. So to begin with our proper discussion, let me introduce to you our objective for this discussion. So the objective is that by the end of this chapter, you should able to identify the steps in the process of analyzing and interpreting quantitative data. Describe the process of preparing your data for analysis. Identify the procedures for analyzing your data. Learn how to report and results for analyzing your data. And the last one is describe how to interpret the results. So without further ado, let's discuss about what are the steps in the process of quantitative data analysis. So there are several interrelated steps used in the process of analyzing quantitative data. So the first step is you should prepare the data for analysis. This involves determining how to assign numeric scores to the data, assessing the types of score to use, selecting a statistical program and putting the data into a program, and then cleaning up the database for analysis. And the second one is begins the data analysis. Typically, you conduct a descriptive analysis of the data reporting measures of central tendency and variation. Then you conduct more sophisticated inferential analysis to test hypotheses and you examine confidence intervals and effect sizes. And also the next step is to report the results that are found using tables, figures, and a discussion of the key results. And the last one step is that you interpret the results from the data analysis. This consists of summarizing the results, comparing the results with the past literature and theories, advance the limitation of the study, and ending with suggestion for the future research. So meaning to say, in data analysis, the results are usually presented in the form of statistics, chart, graphs, or other visual representation. These results help identify patterns, relationship, and insight within the data. So let's proceed to the next topic, which is how do you prepare the data for analysis or how to prepare a data analysis. So the first one here is score the data. When you collect data on an instrument or a checklist, you will need some system for scoring the data. Scoring data means that the researcher assigns a numeric score or value to each response category for each question on the instrument used to collect data. And also, there are many ways to collect data for your analysis, but some of the most common ones are surveys, interviews, observations, experiments, and document analysis. So let's try to look these examples. For instance, assume that parents respond to a survey asking them to indicate their attitude about choice of a school for children in the school district. One question might be, students should be given an opportunity to select a school of their choice. So we have here strongly agree, undecided, disagree, and strongly disagree. And assume that a parent check agree, what numeric score would you assign to the response? So that you will assign the same score to each person to 6 agree. To analyze the data, you will need to assign score to response such as 5 is strongly agree, 4 is agree, 3 is undecided, 2 is disagree, and 1 becomes strongly disagree. Based on these assigned numbers, the parents who check agree would receive a score of 4. Several guidelines can help in assigning numbers to response option. And continuous scales, you should consistently score each question in this scale using the same numbering system in the example above. You should consistently score a scale such as strongly agree to strongly disagree as 5 to 1. And to make scoring easy, you can pre-assign numbers on the instrument to each response option, such as in this example. And the question is, fourth graders should be tested for a math proficiency. So here you can see that the numbers are already pre-assigned and you know how to score each response, because sometimes you can have participants fill in circles for response on bubble sheets, such as those used to aid in scoring when evaluating teacher in college classrooms. And I think that this is the accurate way because it's easy to understand compared to the first example. So one procedure that can aid you in assigning scores to responses is to create a codebook. A codebook is a list of variables or question that indicates how the researcher will code or score responses from instrument or checklist. So based on the table attached here, we notice that each variable is given a name, like their grade level of the students, and also their gender, and many more. Like for example, in variable 1, ID, which is identification number assigned to each student from 1 to 50, and variable 2, which is gender or sex of the student, we have male and female. And now, let's jump on variable 9. Depression consists of a score based on adding all items on an instrument. Before conducting an analysis of score, researchers consider what types of score to use from their instruments. This is important because the type of score will affect how you enter the data into a computer file or an analysis. And the next one is single item scores. A single item score is an individual score assigned to each question for each participant in your study. This score provides a detailed analysis of each person response to each question on an instrument. And this is how a single item looks like as an individual score assigned to each question for each participants. So in some score naman, we may need to sum responses to all of the questions on the instruments such as in the response of the scale scores. In other words, sum score are the scores of an individual added over several questions that measure the same variable. And researchers add the individual items to compute an overall score for a variable. As shown in this table, the three participants, Jane, Jim, and John, have provided responses to 5 questions. The researchers sum score for each individual to provide a single score for a variable representing all 5 questions. And also we have a net or difference scores, are scores in a quantitative study that represent a difference or change for each individual. Some gains may be more meaningful than others. In this table, for each of the 6 participants, we see a pretest math score, a sum score over all items on the test before a unit on the math is taught. And we also see for each participant a post-test math score, a sum score at the end of the unit that represent the overall score on the final test. The net score show how each participant show performance improve in 6 cases between the pre and post test. And now let's discuss about how to select a statistical program. So after scoring the data, researchers select a computer program to analyze their data. Academic researchers generally use statistical program available as software programs for desktop or laptops, or available on campus computers. The hardest part is deciding which software package to use, and here are some guidelines to follow when selecting a statistical program. The first one is find a program with documentation about how to use the program. Program often have tutorials so that you can easily learn the key features and practice them using sample data sets. And another one is ease of use is an important factor when selecting a program. Pull down menus and easy data entry make a program easy to use. And also look for a program that includes the types of statistics that you will use to answer your research question and hypothesis. And make sure that the program can analyze the amount of data in your database, consider how many participants and the maximum numbers of variables that you will need in your analysis. And the last one is locate a program with the capability to output graphs and tables that you can use in your research reports. So after choosing a statistical program, your next step is to enter the data from your instruments or checklist into the computer program. Input data. So inputting data occurs when the researchers transfer the data from the responses on instruments to a computer file for analysis. For those new to this process, this grid is similar to a spreadsheet table used in many popular software packages. So examples of this is Excel. So the table attached here is the example of input data. And I know that it's something blurry, but I will discuss it clearly. So in this table shows a small database for 50 high school students participating in a study on tobacco use in schools. And you see displayed in the first column and the number of each participants followed by an ID number assigned to each of the 50 students. In the other columns are variables that our researcher is measuring. So for example, the gender, grade, parents, and so forth. And you can also assign names to both values and variables so that your printout contains these names and provides an easy way to identify your information. You can assign names to your variables such as parents as well as the values for this variable such as married, divorced, and separated. So after entering data into the computer grid, you need to determine if there are errors in the data or missing data. Error occur when participant in your study provides scores outside the range for variables or your input wrong numbers into the data grid. And missing data may result when instrument data is lost. Individual skip question participants are absent when you collect observational data, or individuals refuse to complete a sensitive question. And you can eliminate participants with missing scores from the data analysis and include only those participants for which complete data exists. This practice, in effect, may severely reduce the number of overall participants for data analysis. Remember that cleaning the database is a critical step in ensuring the accuracy and reliability of the data for analysis. By following effective data cleaning techniques, you can improve the quality of your data and make more informed and reliable business decisions. And that's conclude my part. And the next topic will be discussed to us by Mr. Dalumpines.
So, good morning, everyone. I will be discussing the topic how do you analyze the data? To conduct descriptive analysis, statistics are used to calculate values based on numerical data, helping to describe trends. Various statistics and their computation methods are available in resources like Abelson 1995, Gravitier and Walner 2007, and Wright 1997. In educational research, descriptive statistics are commonly employed to summarize overall trends, measures variability in scores, and determine the relative standing individuals and individual scores. Key concepts include central tendency, variability, and relative standing with different statistical procedures available for analysis, as illustrated in Figure 6.2, which is in the PDF, like the book, the PDF version of the book. So, measures of central tendency are summary statistics that represents a single value within a distribution of scores. They include the mean, or which is the average score, the median, middle score, and most frequent score. In quantitative studies, researchers often report all three measures. The mean calculated by summing all scores by dividing the number of scores is particularly common. For example, in table 6.3, the mean depression score for 10 students is calculated as the sum of scores, which is 818 divided by 10, resulting in a mean of 81.80. This average provides a representation of the overall scores in the sample. So the mean is the overall scores that is shown in the sample. The median is the middle score in a distribution dividing scores into halves where 50% of of scores lie above 50% lie below. It's calculated by arranging scores in rank order and finding the middle value. For instance, in table 6.3 again, the median is 79.5, with 5 scores above the 5 below it, while the median is often reportedly, its utility is somewhat limited. Conversely, the most frequently occurring score offers valuable insight, especially with categorical values in table 6.3. The mode is 76, occurring twice in a sample of 10. For categorical data like peer group affiliation in table 6.4, the mode provides meaningful information unlike the mean, which lacks the significance in this context. Measures of variability. Variability in distribution refers to how spread out the scores are. So it is straightforward on some meanings of variability. In distribution, the range variance and standard deviation are all measures of variability, providing insights into the dispersion of responses in the data set. The range is simply the difference between the highest and the lowest score. So it is said that the range is the difference between the highest and lowest score, which is 60 to 99 in the example in table 6.3, indicating a range of 39 points. So why is it 39 points? So it is the difference between the lowest scores, which is 60 and 99. So if you add 39 to 60, the answer would be 99. So it indicates the range of 39 as it is the difference between the lowest and highest scores. So variance quantifies the dispersion of scores around the mean. It is calculated by finding the square difference between each score and the mean, summing of these square differences, and then dividing by the total of scores in table 6.3. The variance is 173.96, which becomes useful in advanced statistical analysis. The standard deviation, or in short, SD, the square root of the variance, offers valuable information about the spread of scores. In table 6.3, the standard deviation is 13.90. A smaller standard deviation like 7.30 indicates less variation around the mean compared to a larger one such as 13.18. Visualizing these concepts, a theoret- theoretical distribution of scores often forms a bell-shaped curve, which is known as normal distribution. While actual data might not be perfectly matched, this curve, the means of many samples, typically do, reflecting a normal distribution in such a distribution can percentages of scores falling within the specific standard deviation from the mean can be determined, aiding in understanding the distributor's characteristics. For instance, approximately 68% of the scores usually fall within one star deviation from the mean. In figure 6.3, the table earlier, About 95% of scores typically fall within two standard deviations from the mean, which with approximately 13.5% above and below each standard deviation. Percentiles, z-scores, and t-scores are associated with each standard deviation, aiding in understanding relative standing within a distribution. Percentiles indicate where a score lies relative to other scores in a distribution. For example, a score of 94 in table 6.3 corresponds to the 80th percentile, meaning 80% of the participants have scores at, at or below this value. So it means that if the score 94 is at the 80th percentile, it means that the one who got the score of 94 is above 80% of the people that took 80% of the participants, while is still below 20% of the participants. So, conduct inferential analysis. Descriptive statistics are valuable for analyzing descriptive questions, while interferential analysis becomes necessary when comparing groups or examining a relationship between variables. In interferential analysis, the goal is to draw a conclusion about the population based on sample data, as studying the entire population might be impractical due to the size and cost constraints. Three main approaches are used to assess the reliability of sample scores. So the first one is hypothesis testing. This method involves comparing the sample value, such as the mean difference between groups with a population value to determine if there is significance between the difference or relationship. It provides a yes or no answer regarding whether the sample estimate is likely and accurate. So in confidence interval approach, confidence interval provide a range of values that likely contain the actual population mean. This approach offers more flexibility than hypothesis testing by providing a range of possible values rather than a binary yes or no decision. Effect size approach. Effect size measures the practical significance of group differences or relationships between among variables. It allows researchers to evaluate the magnitude of differences and make judgment based on the context of the study. Each approach offers unique insights, with some researchers favoring confidence intervals in effect sizes over traditional hypothesis testing due to concerns about misinterpretations and errors. Preventing all three estimates of hypothesis testing, confidence interval, and effect sizes in research reports is recommended to provide a comprehensive understanding of the results. So, this approach prioritizes a more comprehensive understanding, as the other two compared to this one requires like a more hypothetical way of testing things, while as effective size approach only measures the scale of or intervals of the given values in order to determine possible results. So that's it for this part. So how do you another topic that I would be discussing is a short topic. How do you report the results? So in quantitative research analysis, you first describe trends within your data using descriptive statistics like mean, median, and standard deviation. So this is tackled earlier. So then you compare groups or variables using inferential statistics to draw conclusions about the population. So this process helps answer research questions and test hypotheses about individual behaviors or characteristics. So, first one is tables. So, I mean, this is the one that is used to determine like possible, or like you report the results by um, representing them in these ways. So researchers often utilize table to condense and present statistical findings related to their research questions or hypotheses. These tables are summaries of quantitative data arranged systematically in rows and columns for clarity and easy interpretation. So it is very familiar to us, these tables, as we are exposed to them while we were on the first year. We are exposed to them earlier, even in college, because we were able to have our research subject rin while we were at grade 12, and tables are commonly used to determine or collect data from people, or like the target people that we are aiming for when doing our research, um to give us a clear, and it makes an easy interpretation of the data that is given to us. So figures, a visual representation of data, concepts, or ideas. Figures can take various forms, including graphs, charts, diagrams, photographs, or illustrations. They are used to represent information in a visually compelling and informative way, often enhancing the understanding of complex concepts or relationships. So in figures naman, it is used to in a more complex setting, as like it uses like different types of what do you call this, like charts and diagrams, as it is said in the description of figures. So it means that the figures have different ways to represent data, and can also be used to describe or illustrate a more complex set of data. So that's it. Presentation of results. Researchers present detailed information about the specific results of descriptive and interferential statistical analysis. They typically provide a comprehensive overview of the findings derived from their data. So, in presentation of results, this is the moment when you present your results. So the ones that you got from tables, or whatever you use for your research, then it is needed. It is essential to uh, translate the data that is given, that you have collected, in order for you to present it properly, and also to get the needed knowledge that you need in order to continue your research. So that's all for my part.
Once again, good morning to everyone. I'm Hazel Costales, and I will be the one to discuss to you the last part for this topic. Now, how do you interpret the results? The first one is summarize the major results, advanced
Explain why
limitations,
the results
suggest future
occur.
research, and the last one is re examine data analysis and interpretation in the parent involvement study. The first one is summarize the major results. This only means that the research process involves summarizing major findings and presenting broader implication for different audiences, discussing the study's positive implication and significance for various stakeholders. So it is important for the researchers to summarize the main results to make the key points clear and easy to understand. This helps show the importance of the study for different groups. The summary also focuses on the overall conclusions, not only the specific details. And through this allows researchers to discuss the positive meaning and impact of the research. And providing a summary makes it simpler to share the key findings with various audiences. The second one is explain why the results occurred. The results occur due to the research methodology, the theory or conceptual framework that guided the research, and the existing literature. The limitations of the study were due to the factors such as inadequate measures of variables, loss or lack of participants, small sample sizes, errors in measurement, and other factors typically related to the data collection and analysis. The results of a study are often based on the predictions made from a theory or conceptual framework that guided the development of research questions or hypotheses. These kind of predictions are then tested through the research process. The explanation of the results also involves discussing the existing literature, indicating how the results either confirm or disconfirm prior studies. This is why past research studies are often presented in the explanation of the results. And the third one is advanced limitations. Researchers highlight potential study weaknesses such as inadequate variable measures, participant loss, sample sizes, and measurement errors. These limitations are useful for future research and help determine the generalizability of findings to other situations. They also aid in recommending similar studies. So by advancing these limitations, it can provide a useful bridge for recommending future studies. Limitations also help readers to judge to what extent the findings can or cannot be generalized to other people and the situation. The fourth one is suggest future research. Researchers should suggest new studies based on their current research, providing guidance for future studies and highlighting areas for exploration, while also highlighting limitations and providing a clear path for further learning. So here, when researchers finish a study, they should include some ideas for what kind of new research should be done next. These suggestions for future research are important because they point out areas that still need more investigation based on the results of the current study. The future research directions are connected to the limitation of the present study, things that the research weren't able to fully explore or answer. By providing these future research ideas, the researchers are giving helpful guidance to other scientists who want to learn or more about this topic and build on the knowledge gained from this particular study. And the last one is examine data analysis and interpretation in the parent involvement study. So in statistical approach, the researchers used multiple regression analysis to examine the relative importance or contributions of four key factors in predicting two outcomes. The first one is home-based parent involvement. The second is school-based parent involvement. So here we have here the four factors examined. The first one is parents' rule construction, their beliefs about their responsibilities as parents. The second one is parents' self-efficacy, their confidence and their ability to be effectively involved. The third one is parents' perceptions of teacher invitations, how welcoming and encouraging teachers are. And the last one is parents' perceptions of adolescents' invitations, how much their teenager wants their involvement. We also have here the key findings. The regression results showed that parents' self-efficacy and their perception of teacher invitations were the strongest predictors of both home-based and school-based involvement. These suggest the importance of building parents' confidence in their ability to be involved, as well as fostering school environments that actively encourage parental participation. We can see here also the authors acknowledge limitations such as the cross-sectional design and self-reported nature of the data. The proposed future research should examine these factors longitudinally and explore additional and contextual influences on parent involvement. And the goal is to provide a concise yet comprehensive overview of the key statistical approach, the main factors, examine the critical findings and any note limitations or future research directions, all within a single slide. And that's the end of our report. Thanks for listening and watching, Pop.